Hello everyone, welcome to MechTech 40. Today we'll discuss about the mathematics part. So in our last previous HAL exam, we have some questions on mathematics, and if I will analyze those questions from the feedback of the students, the question there is a there are some questions from numerical method. So today we'll discuss about some of the theory portions regarding that. So let's start with numerical method. So there will be we'll start from Gauss elimination or Jacobi method and Gauss Seidel method. So if we'll write three simultaneous equations as a1x plus b1y plus c1z equal to d1, a2x plus b2y plus c2z equal to d2, a3x plus b3y plus c3z equal to d3, and arrange this in such a manner that mod of a1 is greater than mod of b2 plus mod of c1. That is, your absolute value of a1 is greater than b1 and c1. So there has to be one term in all these three equations, and these three equations will be arranged in such a manner that a1 will be more than b1 and c1, and in the second equation b2 is greater than a2 and c2, and in the third equation c3 has to be greater than a3 and b3. So here a1 will be more, here b2 will be more, here c3 will be more in a matrix, if we will form a matrix of 3 cross 3. So we'll be writing x as d1 minus b1y minus c1z by a1. Similarly, y will be from the second equation, that is d2 minus a2x minus c2z equal by b2, and similarly z will be from the third equation, that is d3 minus a3x minus b3y by c3. So we have got three equations. So in case of Gauss elimination or Cos Jacobi method, we'll obtain x1, x2, x1, y1 and z1 as the first iteration. So we'll get x1, y1, z1 is our first iteration. So here we'll get x1 by putting x1 will be, we get something, and this value we'll get by putting y1 equal to 0, and sorry, here by putting y equal to 0 and z equal to 0 in this equation. In this equation 1, if we'll put y equal to 0, z equal to 0, then we'll get x1. Similarly, for y1, we'll get in the second equation by putting x equal to 0. Similarly, z equal to 0. Similarly, in case of third equation, to obtain z1, we have to put x equal to 0 and y equal to 0 in our equation. So x1, y1 and z1 are first iteration. Similarly, for x2, y2 and z2, we have to obtain from equation 1, equation 2 and 3 by putting x1 value, y1 value and z1 value as per the requirement for the second iteration. So it has to be in Gauss elimination or Gauss Jacobi method. Then now come to Gauss Seidel. In case of Seidel method, there is a bit difference. What is the difference? For we'll obtain first iteration, that is x1 from equation 1, x1 from equation 1, and that can be obtained by by putting by putting y equal to 0 and z equal to 0. But in case of y1 from equation number 2, we'll obtain this by putting x h. x1, as we have obtained x1 from the equation 1. So we'll use that here, and z equal to 0. So we have already obtained x1, y1. So what we will obtain next, that is z1. z1 from equation 3. Right. So for 3, what we will have to get? z1, that is a first iteration value, and that we will obtain from by putting x h x1 and y as y1. So this is the Cos Seidel method. Similarly, we can obtain x2, y2 and z2. Okay guys, then let's come for bisection method. Bisection method is like intermediate value theorem. So here if f of x is a function that can be a polynomial equation of fourth power, fifth power, second order, third order equation, anything. F of x is continuous between a and b, and f of a and f of b are of opposite sign. So we can write this f of a into f of b. It has to be less than 0. So if this is satisfied, then there exists at least one root between a and between a and b. So how we'll obtain that? So for that thing, let us try obtain our first. Let us assume approximate value be approximate like the, and let its approximate value. The root will be finding the root between a and b. So root lies between a and b. So let us find the approximate value of that. 0 will be a plus b by 2. And if we are getting f of x0 equal to 0, then x0 will be what? Our root. But if we will not get as f of x0 as 0, if we are getting it some value like positive or a negative value, then what we will do? According to the sign, we will take the interval as x0 comma a or x0 comma b. Then we will go for x1, x2, etc. So by the first iteration, we will obtain an interval of b minus a by 2. And if given in the question that the error in the approximation of bisection method is less than epsilon, then number of iteration is asked. So how we'll do? There is a formula for that. Let's remember this formula. 1, that is b minus a divided by 2 to the power n is less than error value. N is the number of iterations. So that's it for today guys. Thank you.